Hey everyone, and welcome back to the channel. Today, we're diving into a story that sounds like it's straight out of a sci-fi novel, but it's happening right now. China is taking a massive leap toward building a base on the moon, and it all starts with a few humble bricks. Just last week, a set of experimental lunar soil bricks made their dramatic return to Earth. These aren't your average construction materials. They've just spent an entire year orbiting our planet aboard China's space station, exposed to the brutal conditions of space. The Shenzhou 21 spacecraft brought these special blocks back, along with 3 astronauts wrapping up their 6-month mission, and the initial news is incredibly exciting. Scientists who got the first look are calling it a promising proof of concept for the future of lunar construction. Imagine that, the very first building blocks for a home on another world. One of the lead scientists on the project, Associate Professor Zhou Yan, shared his relief and surprise. He said that when they opened the container, the samples were in good condition. There were no dents, no holes, none of the damage they had feared from potential impacts with tiny meteorites or space debris. That alone is a huge win. The only noticeable change was that the bricks seemed a little lighter in color, a mystery they're now eager to solve. So, what exactly are these bricks? There are 34 of them, each weighing about 100 grams. They were created using materials specifically designed to mimic the properties of lunar regolith, that is the dusty, rocky layer covering the moon's surface. The real genius is in how they were made. The team used advanced techniques like hot pressing, electromagnetic induction, and microwave sintering. This process compacts the material so intensely that the resulting bricks have a compressive strength about 3 times greater than standard earth bricks. This extra toughness is absolutely critical for standing up to the extreme environment of space. But strength is only part of the puzzle. The researchers were clever in their design. Qin Yiheng, a graduate student involved in the project, explained that some of the bricks were sent up as complete blocks, while others had pre-made seams cut into them at 45-degree angles. This was done to test how their mechanical properties and structural integrity would change after a year in orbit. It's not just about whether they survive, but how they wear down and how they might fail. This experiment is looking at the whole picture. Beyond just strength, the team is meticulously testing how the bricks' thermal behavior and radiation resistance have been affected by their year-long space vacation. To get the most accurate data, they kept an identical control group of bricks right here on Earth. By comparing the spacefaring bricks to their Earth-bound twins, scientists can isolate exactly what effects the vacuum, temperature swings, and radiation of space had on the material. This isn't just a one-off test. This is part of a much larger, multi-stage experiment. This was the second batch of samples to return, and there's a third batch still up on the space station right now. Professor Zhou explained the long-term vision. By comparing all 3 batches, they hope to identify patterns and build a predictive model. This model could forecast what these bricks would look like after 5, 10, or even 20 years of service on the lunar surface. Essentially, they're recreating a way to predict the future of a lunar building's lifespan without having to wait decades. This brings us to the big picture: China's ambitious lunar program. The goal is clear: land astronauts on the moon by 2030 and have a basic version of their International Lunar Research Station operational by 2035. That's just over a decade away. Building something that complex, so far from home, presents an almost unimaginable logistical challenge. The cost of launching materials from Earth is astronomical. Every single kilogram sent to the moon is incredibly expensive. That's why this brick experiment is so critical. The entire strategy hinges on what's called In-Situ resource utilization, a fancy term for living off the land. Instead of shipping everything from home, the plan is to use what's already on the moon. This means using lunar soil to create building materials, harnessing solar energy for power, and extracting useful minerals from the surface. These small, 100-gram bricks represent the key to unlocking this strategy. If you can 3D print or manufacture your own building blocks on the moon, you drastically reduce the mass you need to launch from Earth, making a permanent lunar settlement financially and logistically feasible. The implications are staggering. We are witnessing the foundational steps being laid for humanity to become a multiplanetary species. It starts not with a giant spaceship, but with a small, super strong brick made from simulated moon dust. The data from these return samples will be analyzed for months, feeding into the next generation of designs and the ultimate blueprint for China's lunar base. We're on the cusp of a new era in space exploration, where we don't just visit other worlds, but learn how to live and build on them. It's an incredible time to be watching the skies. What do you all think about this? Could we see the first lunar buildings in our lifetime? Let me know your thoughts down in the comments. Thanks so much for watching, and if you enjoyed this deep dive into the future of space construction, don't forget to like, subscribe, and hit that notification bell so you don't miss our next video. See you next time!